Supplied software is primarily open source through the use of the Snort intrusion detection platform and some additional software used for alert forwarding. And without further ado, I'd like to show you a quick demonstration of this capability. What you see here is a popular open source security Linux distribution called Security Onion. And one of the reasons I chose this was because A, I could forward alerts from my IoT sensor and store them for a long period of time, and for B, I could use the popular tool called Snorby to enrich the context of the alerts. So what you see here is an application running remotely on my Raspberry Pi called Barnyard, and it will gather alerts and it will send them to the VM that I have here running. So what you see now is raw alert data being sent to this VM in its most basic form. As you can see, it's not totally easy to be able to do analysis on these kinds of alerts. It doesn't give you a lot of context. So for that, we will turn to Snorby. Snorby is just a web front end that correlates alerts from all different types of sensors that send it information. I have a couple of sensors set up, and you can see the histogram of alerts over time, and the way that it categorizes and stores alerts. As you can see here, we have a number of different alerts that are showing up from my PyOT. And what it allows you to do is it takes that wall of text you saw before, and it gives it a much greater context. It breaks out the protocol versions, and it gives you a lot more flexibility with the way that you can look at and do research on these kinds of alerts. And that concludes my demonstration of this capability. If there are any questions, I'd be happy to take them now.
So Ryan, are you mainly listening for ICMP or different protocols going across?
I apologize, I could repeat the question?
Are you listening for other protocols other than ICMP, or is it just exclusively ICMP?
Currently, I have MQTT, which is the message telemetry data, which is a popular RT protocol, and I rebuilt a Mirai sample that was scanning for Telnet.
Still port 23 open, wow.
Yeah.
Yeah.
It's all in line. I rebuilt it from scratch using TCP rewrite, so it's completely isolated.
Oh, good. Yeah, what was the big challenge in getting this done?
The big challenge, honestly, was doing it all by myself. In hindsight, I probably would have tried to put together one or two other people to help with this. The other big challenge was getting it to run on the ARM platform using my Raspberry Pi. I'm not the strongest Linux guy in the world, so when it came to supporting a different architecture altogether, I ran into some hurdles there that really kind of helped me out for a long time.
That'll do it. Yeah, I see the Mirai bot is really, it takes advantage of so many things. There's so much room out there to help users. It's a good product.
Exactly, yeah.
Anybody else doing anything like this?
So I did do some research, some correlative research when I started this project. I did find out that literally the same month that I started looking into this, D-Link had put out a home appliance that did something vaguely similar in the IoT space to look at your home cameras and some of those kinds of things that you use in the house.
Thanks.
Hello everyone, my name is Nate Ferrero and I created the Raspberry Pi. This is a low-cost forensic computer using the Raspberry Pi motherboard. This was done to increase skill of students with open source tools, which are often considered subpar to some of the more expensive options. This was also done because I feel there's a place for a forensic tool like this. It's not going to compete with the tools that are $3,500, but it is very capable of doing very specific things like wiping hard drives or even creating images of other drives. Watch for demonstration videos to be posted to my website, and I hope you enjoy it. Thanks.
All right, Nate, you should be good to go. He's muted. You're muted at the moment.
All right. Hello, everyone. My name is Nate Ferrero. My student innovation project was the Raspberry Pi as a forensic workstation. So the goal of this innovation project was to create a low-cost and highly capable forensic solution. To accomplish this, a Raspberry Pi board was paired with a touchscreen and open-source software. This created a forensic solution that is around 10 times cheaper than other similarly featured options that are available. If the Raspberry Pi board is used with without a touchscreen attached, these savings are around 100 times cheaper than other forensic options. I used the Raspberry Pi 3 Model B board, which costs $35. This was paired with the official touchscreen and case. The resulting device cost around $200. This could also be done without a touchscreen, which would greatly reduce the cost, but would also affect the mobility of the hardware as well. Either approach is still cheaper than other solutions currently available. Some of these tools are the Tableau 2X1, which costs $3,500, the LogiCube Forensic Falcon, which cost around $3,100, and another option I used in the testing was an HP laptop, which was running Paladin 7.0.2. The hardware for that computer was around $1,000. The Raspberry Pi device uses open source software. Kali Linux was used in this instance to keep costs low. One advantage of this approach is the ability to customize the software to increase capabilities and functionality of the project. Tests were run to determine the performance of the Raspberry Pi. The original proposal called for the performance to be within 30% to be considered acceptable. While this number was not met, I believe the performance difference of roughly 50% proves this approach is quite successful and worth investment. I believe much of this difference in performance can be associated with the USB 2 ports that are on the Raspberry Pi board. I also believe the price difference makes this performance gap acceptable. Having said this, the addition of USB 3 ports to the Raspberry Pi board should help close this performance gap, which will make the device even more attractive. While I believe this device is perfectly capable in its current form, there are some tests I would like to perform in the future. One idea initially considered was the utilization of a more powerful board. This was not pursued due to the increased overall cost of the project. I believe the performance gap would also be decreased. This may be attributed to the faster processors on those more expensive boards, USB 3, or a combination of those two items. These other boards may also allow the use of full versions of forensic distributions, such as SIFT Workstation, Kane, or Helix. I would also like to work out a method of using multiple Raspberry Pi boards within a large wiping station. This would require a 3D printed case and possibly even the need of a customized graphical user interface to allow easy control of the wiping station. By utilizing 10 Raspberry Pi boards, a total of 10 or more hard drives could be wiped at a time, and the cost would still only be around $500 depending on how much it costs to print a case. This would be incredibly useful and capable for any forensic professionals. If the capabilities to image using the EO1 file type could be added to the wiping station, this could even be used to create forensic images of multiple tribes at once. Next is a demonstration of the Raspberry Pi in use.
Yeah. Nate, we're not able to see your screen. It's not sharing at the moment, so the demo's not showing up.
Okay. And of course, let me find that video real quick. I'm sorry.
So we still don't have screen sharing for you.
You haven't seen any of my presentation?
Nope.
Okay. Well,
But we got the audio, and the audio was fine.
I'm glad that worked at least. Okay.
Little technology issues. Well, if it's not working, we can just move on to questions.
It's working.
Now I can't find my PowerPoint. The Raspberry Pi is a very capable forensic tool. While initial performance goals were not met, I believe the project was a success because of the extreme cost savings from this approach. These savings can be measured in the thousands of dollars. The Raspberry Pi can be attached to an existing monitor to increase cost savings, or paired with a touchscreen in case to increase portability. While there is a difference in performance, it's not large enough to ignore the Raspberry Pi as a valid alternative. This gap in performance may be reduced even further simply by an eventual upgrade from USB 2 to USB 3 ports on the Raspberry Pi. Functionality can be extended even further by creating a wiping station that is also capable of imaging as well. That is the end of the presentation. Sorry you only saw one slide.
I would just say one quick question. What was the biggest challenge you had for this?
The biggest challenge that I faced was getting Kali Linux to work. I attempted using the full version, which worked until I restarted the device. At that point, there's something in the code that did not allow the touchscreen to display any information. I went back and loaded the distribution specifically designed for the Raspberry Pi, and it worked. So then I started loading all of the modules back in, and when I loaded all of the modules, it disabled the touchscreen functionality again. So I eventually just loaded the forensic tools module, and that allowed perfect functionality after that.
Okay. Yeah, I guess that's really all the time we have, but thank you.
Yeah.
My name is Gary Linus. talk to you about my SIP project, AlphaKeeper. AlphaKeeper is an app that helps you take notes and keep them organized. It does this through the use of several features: your note-taking feature, your camera features, and your audio feature. And the way it does this is by giving it timestamps every time you create a note. You can create it simply by typing on your phone or using your voice-to-text features on your phone to type your notes. You can take snapshot photos, video recordings, and audio recordings, each one creating its own folder with the file in there with a timestamp of when that file was created. It was mainly geared for digital forensics investigators, but anybody could really use this app. Thank you, and stay tuned at the website, and I hope to see you at the 6th Fair so you can learn more about my project.
Aliens for communicating. All right. You ready to go, Esker?
No audio.
Not sure if you're able to hear us. If you're ready to go, you're...
But the rest of it.
He's texting. He said he's having issues sharing his screen. I don't think he can hear us either.
Yeah.
All right. So that's our last presentation here.
We just wanted to thank you all for coming to our first group this morning and kicking off the Spring 2018 SIP presentations. As Robert said, this is a culmination of a lot of hard work by both students, faculty, and staff here that have seen you all to the end and to the finish line. So please take some time to circle back to the large commons at around 3 p.m. There'll be munchies, of course, and you'll be able to see and experience and talk with some of your peers about their projects and their designs. Your faculty will be there as well. And even more important, make sure you circle back to this theater tomorrow at 2:30 for our awards ceremony, where the winners will be announced and a few other student awards will be given out. And we look forward to seeing you all there. Thank you so much for your time and your dedication, and thank you to your amazing instructors and support team that helped put this together today. Thank you, guys.